Here's another 88K model railroad video, and in this video we're going to wrap up the WIO boards, and this is the final or the last two boards, and it's the 8266. And I had these boards and I thought might as well finish the videos or finish the series with these two videos instead of leaving them out. Now these modules are pretty small, they don't have very many IO ports or GPIO pins, and a lot of them are used for other aspects. But you can use the I2C square interface, and that allows you to utilize the expansion boards. So it's worth going after and kind of showing how to set that up. So that's what I'm going to do in this video real quick. Now there's two types of boards, or chips rather. You can identify them by the type. The initial type is the 8266EX, and then the other newer type is the 8266 mod, and the mod is on the right hand side. It has the square aluminum casing, which is similar to the other units. So whereas the EX is the old what they call the SoC, which is the system on chip. So that's how you can tell the difference. The firmware is pretty much the same. It uses the Room 2 firmware, and the EX is an older AT firmware, but I think the Room still works on it, or the Room 2 still works on it. With the IDE, when you want to flash the OTA, you can set up with the ESP8266 generic board, and then that will work. And then you change the rotor file, you change the WPS to false, and it's noted inside the sketch. So for the I2 or I squared C interface, there's two types of chips that you can use. That's the PCF8574, and the other is the MCP 23017. Those are the two boards. They can get you the 16 IOs, but the way the I squared C works, you can daisy chain them and set the address, the IC square address, and you can increase it from the 16 to the 32 IOs. But having that many IOs, I think you cannot run all of them at the same time, because what happens is it overloads the chip itself, because the chip can only handle I think 150 milliamps. So each one of them are like 25 milliamps when they draw. So each one of the pins. So you don't want to have all of the pins activating at the same time. So with that said, what we're going to do is swing over to the bench and look at the boards, and then also watch the configuration. So let's get to it. So here we are at the computer first. Let's verify everything on the board itself to make sure that it's working and we're seeing everything we need. So I need to connect in to the PC. There, you heard it connect, the COM port. We can go into WIO, the maintenance, access the maintenance, scan the device, pull up the COM port and connect to the COM port so we can read the board. So it's going through accessing, and now it's looking at the configuration of the board. We can see that it has the node ID. It's looking at the server. It's connected to, let's see, yeah, it says it's reloading and it's trying to connect to the server again. Oh, I know. Here, let me pull up the server. I started this up without accessing the wiki. So minimize that. So now we see that it's connected to the server. I've got the server up and running. So now we know that the board is good. We know that it's up and running and it's connecting. So what I'm going to do is I'm going to disconnect it from the COM port and then let it power up by itself via a adapter. So that way it's kind of online the way it normally should be without a COM port. So we can do a query, and here we see it. So it's up and running without being connected to the COM port. So we know that it's on its own now. So with that done, we can look at the task at hand. So let's pull this up. Oops. Look at this first instance here. This is the board. We've got, here's the pinouts. Now, one of the caveats for using the PC F8574 IO extender is the channels. It should be set up to start with, or I shouldn't say channels, but address. To start up with address 22. The way that we make the connections between the two devices, you have the what they call the SDA, which is the serial data, and then the SCL, which is serial clock. This is how the two boards communicate with one another. Then you have the ground and you have the VBus or the VCC, and that's how it's powered. The next thing is the address. So we have to get the address initialized or set, and that's what these jumpers do. There's three sets of the pins. You have A1 at the top, then A2 at the top, then in the middle is A1, and at the bottom is A0. For address 22, A1 is high, which this shows the plus and this is the minus. So when you put the jumper to the left, that indicates that it's plus, so that's a 1. And the jumpers that's left or remain on the negative side or the minus side, that means that it's 0. So in order to get the address of 22, A needs to be high, and then 0 or A0 needs to be low, and A2 needs to be low. So we can see that the pins will be this to the right, and then the upper and lower will be to the left. So let's go to the bench, and we can get that configured, and then also get the 8574 connected to each other. So let's do that. So here we are at the bench. We've got the computer going. We're going to look at Rocrail. We're going to make the address assignments. Then after that, we're going to power the board up, and then we're going to verify the pins. So first off, remember this is the pin A2 is here on the lower because the board's upside down. Then the middle pin is A1, and then this pin further away is A0. And this left side is the negative, and then the right side is the positive. So remember, A1 had to be high, and then A2 and A0 is low. So we connect this to A1, that's high, then A0 is low, and then A2 is also low. And these pin configuration is going to show what the address is, and the address is going to reflect the 8 channels. So you have the 8, 16, 24, and then the 32. And based on the way these pins are configured is how you're going to get those addresses. So now we're looking at 1 through 8 as our pins. Now we're going to connect in the power. The VCC is on pin 10. The ground is on pin 11, and I'm using 10 and 11 from the as it references to the breadboard, so it's easier this way because I can't see over the camera. So then this is the data, which is a serial data, and that's on 14, and then the serial clock, which is the SCL. So it's SDA, and SCL is on 15. So now we have everything wired, and let's power up the board. There, it's powered. We see the blue light. Blue light's flashing. That means that it's connected into the server, and we can see the controller update. It shows that 90's added. So if we open up the control, then go to sensor monitor, and with the sensor monitor we can see the node and then the addresses. So the way that it counts from 1 or 0 through 7, and this last pin is an interrupt. So we're going to hit the first one with the ground, and then that should give us the indication that the sensor's triggered. So let's put a ground here. We can pull the ground off of this pin 11. And if we go here and hit pin 1, now we see the state changes here from from 0 to 1, and if we go through each one of those, we can see it trigger. And there. Now we see all 8 of the pins have been triggered, and now we see that we have the input and the sensors working, or the IO is working from the sensor perspective. If we go and drag this as usual here, we should be able to trigger this, and there you see that that sensor triggers onto the map or the plan. So that's it. Now this configuration works. It's the same for the board as well as this board here. The way the I2C works. There's another extension board which is called the MCP23017. That chip works pretty much the same. You have to set the address. Once you set the address, then you can allocate based on the address, which channels or the addresses that you want to use. So it's pretty much the same. This is probably the last video that I'm going to do of all of these I/O boards, because now I've covered the gamut. I almost left this out, and then I thought about it. I have the boards. Just go ahead and complete everything, so that way people have access to all of the boards, and if they want to turn them up, then they have something to reference. And then you can see the connections here. I made them. It's all on the video. You just have to follow them and you will be okay. So this is going to end this whole segment for the boards. Hope you guys enjoyed it. Hope it helps you out. And like usual, subscribe, like, and share. We'll talk to you later. Bye.